Thanks. I've got a nice introduction. We're going to see a small, but essential activities, how they can be improved by modern tools, and in particular IntelliJ IDEA, which is a new addition to this material that I started to develop this year. So yes, I participate in OpenJDK development, and I really like to participate in Java user group meetings. I also take questions. And I work with a company named BellSoft. We participate in OpenJDK, but also in GraalVM, which is the major topic we still, and Linux. We have our own minimalistic Linux that empowers the smallest and secure containers with Java, of course, and our own distributions of JDK, which is the default and recommended JDK for Spring Boot containers, and distribution of GraalVM called American Native Image. So we know GraalVM is great. By the way, who has tried GraalVM? Right? Okay. I still see some gap between initial experiments and adoption of GraalVM, but it looks like in 1-2 years we are going to see more production adoption of this technology, which makes it an interesting thing to explore. And there's a huge room for IDE and other related tooling around this new technology. So it rapidly develops itself. Not really itself, it's developed by community, by local GraalVM team. And there are many benefits. Like we have no visible warm-up problem. There is still some warm-up, but it's not like the traditional hotspot JVM warm-up. And some great performance results. I would say that's a viable alternative for traditional JVM deployments. Of course, we can take some real-world example, and this is the most famous sample application that we can use to demonstrate how we can debug this GraalVM Native Image binaries. So we are used to regular Java debugging, right? This is a technology that exists for over 20 years, and we just are used to providing extra options, attaching an agent, and all that. But many things changed since during the past 20 years. We now have containers, and probably even traditional Java debugging will change, or it already changes. Like we do it slightly differently. We have to make different settings, make it available or possible in the cloud in different cluster deployments. So yes, we can use even command line tools, and those command line tools are still part of JDK. We can use text mode Java debugger, and actually it uses some prompts, but it's not an LLM. This is a simpler technology. Now, of course, we need to provide some additional Java options, so we'll have to restart our application. But it's the same binary. It contains debug information. And we have to provide some access to necessary ports to attach our debuggers. But that's the Java debug. And here's the principal schema of how all debugging in this IT world works, right? I would say we're in Chicago, so looking at those coasts. So here we start from the West Coast, which is our host machine, from which we debug. So this is, I would say, the key diagram. If you get this, all the rest is easy, right? And it's actually not that complex. So we have this host where we have our debugger, and we provide or get some information from other parts of this triangle. So this debugger can be IDE or a GUI tool or a command line tool, or it can be even our own one. But it goes to that second post. And here we have our target machine, where our binary is running. In case of native image, it's our results in native image binary, which is built as a debug one, it's a debug binary. In case of Java, we always have the debug information. We actually can strip it, but it's still debuggable. And also, we must have some kind of an agent, which in case of regular Java is built into JVM. It's a part of the spec, so we can debug that. In case of native image, we have to start some agent if this part of the system is remote. And the favorite here is the third coast, right? Which is an analog of Chicago, but this is the place where we perform the build to assemble the binary, and all those three can be different machines. That can be single machine. That can be different environments on a single machine. Those can be two machines. But actually, it depends. And our sources, we need them to debug the application most frequently. They must be in the end located or locatable on our host machine, but as well as debug information. And that debug information can be, it's generated during the build step, but it must be available during debugging. So it can be retrieved from the target, or it can be retrieved from the build machine. Right? And again, it can be the same machine, like the build machine and the host, or all three can be the same machine. So we can build our application, generate the debug information, assume this is the same machine, and just leave it as is. Or we can build our debug binary, ship all the symbols and other parts, external parts of the debug information to the target, and later retrieve them during the debug session. That's kind of simple. So native binaries are different. We debug them as platform binaries. So they contain platform-specific debug information. Unlike Java, which is write once, also compile to bytecode once, run anywhere. Those are platform-specific, and platform support differs. So the level of platform support is the best on Linux. We recently implemented some macOS support, enhanced macOS support, but still Linux is the most convenient one. And actually, that's the one we need, because nowadays we run everything in containers. The platform may vary. It can be x86 or ARM, but ARM64, but we most likely run that native images in containers, which influences debugging scenarios and influences tools that we use and how we use them. And besides, we work and tools work with debug information. And debug information support must be implemented for every platform. The current support level, well, it becomes better and better, but still it's not, I would say, a fully complete solution. And there are some complexities related to the format of the debug information, because this is the debug information invented for C++, but we work with Java in case of native images. And as I mentioned, we have to recompile the code to contain the debug information. So if we do it manually, if we prepare the binary or container manually, we have to change compile time flags for the native image tool that can be made, that can be done inside, for example, POM.xml or our Gradle configuration file. So we must enable debugging. That's essential. And we also can make the experience better by lowering the level of optimizations to keep the binary structure close to our original program structure, and to keep more debug information inside the binary. But that makes the binary larger, obviously. It's not that smaller binary for the native image that we used to think of. It's a larger binary, and it's a different binary. So debug slightly different thing if we really want. But the thing here is, it's not a developer who's supposed by the native image. I would say still it's mostly like us, vendors, who provide support for the underlying problems with native images. Otherwise, we can just compile to and run a regular Java application using traditional JVM and see what happens inside it. Well, as I mentioned, there are specific things you can do on different platforms. In particular, it's now possible to debug on macOS if you use Library. And you see the binary becomes larger. Some numbers are here. And you can use command line tools. Surprisingly, well, LDB works, and it works in a different way. But as I mentioned, we focus on Linux, right? We can again use command line tools. In this example, we can start a container, forward some ports, add capabilities, right? Already sounds complicated. We're just starting the application. And when we connect, when we install necessary tools, including GDB, which is basically a thing that allows us to connect from the outside with any GDB-capable client, GDB itself. And we can connect and debug this application using command line. But to make the experience better, we need all the dependencies. And again, it's sometimes tricky to generate all the sources. Some part of this is provided by plugins that compile the native image, but not all the sources are included by default. So we need to collect all the sources. So it's complicated. Obviously, we have better tools that will do it for us. And I started in spring this year to explore the space of tooling. And surprisingly, the IDE that had the best support out of the box wasn't one of the, that was this. And after my presentation, guys from JetBrains appeared and started to ask questions. So we decided to join our efforts to provide better tooling in the IDE. And, partner with JetBrains. So yeah, I will show an Eclipse, so you can find an article how to set up some debugging with Eclipse. It's not that hard, but the overall IDE experience, it's not that good. Now in IDE Ultimate, there is a plugin that supports native debugging. There are actually at least 2 plugins that you need, not as a dependency. And release has just happened, I don't know, 5 days ago or so. And there's a release note saying, okay, the debugging experience has been improved. And it's still being improved. I would say many things don't work, but the base ideas are now crystallized. So I mentioned Linux, and that's true, right? The initial Eclipse experiment showed that it's complicated. We need GDB for the best debugging experience. And surprisingly, the situation is much better with JetBrains, because unlike typical approach where you need to find the GDB by yourself, they built one. They built a client part for all the platforms. Although GDB is not officially supported on macOS, for example, they have a recent version, at least a part of it, inside their IDEs. And it's, of course, free and open software. Anyway, we develop applications for containers, so we can run them inside some virtualized environments, simulating all the containers locally, or we can, in fact, run them remotely and access those remote containers from our IDEs. And those are slightly different scenarios that require some setup. So let's look at debug configurations we can find. Anyway, this is the application, and I have some breakpoints in it. Right.
Application by your company?
No, it's one of the most famous example from Pivotal. It's Pet Clinic Spring Boot application.
So you just mentioned that intelligent IDE and BellSoft is one, integrated this two software together or what?
We just study what's the best user workflow to support native debugging in IntelliJ IDE. So from our perspective as a runtime vendor, and their perspective as the IDE vendor.
Who owns the IntelliJ IDE? The JetBrains?
JetBrains.
Oh, JetBrains.
By the way, we help to support updates in JetBrains runtime and security updates. So we study debug configurations. So for Java, we have the regular ones, right? We have, for example, an attach configuration that allows us to connect to an existing process, right? So we have that module plus path that gives us an ID, the idea of what are the sources, where to look for some details about this project, this running process. And even if we work with a traditional JVM, it has special debugging notion, special debugging extensions for Spring Boot. I won't show you that much, but to debug native images, we have different configurations, different types of run and debug configurations. So this is GraalVM Native Image, GraalVM Native Image. That's for running, starting new process with GraalVM, and we have native attach. So for example, if we want to run one, you see there are new settings.
Can you
If you remember, so I don't remember the combination. You have it in your mind. Yeah. I'll make it simpler. Okay, sorry. We can just change the screen resolution. Yes. That will help. Okay. Is it better now? Awesome. So let's get back to the configurations. So in this example, I'm going to run it on Debug. And I have a special target set up here. And this target says that I will use an existing image. Right? And this existing image has a tag. I get it from the local repository, which is kind of tricky because this is an image built from custom token. So these are current requirements. You have to have GraalVM available in the resulting image that you specify as the target. It will change. So the current work is aimed to provide support for any image that you can build just by starting an ephemeral container that will work in the same PID space with your target image. So not to have this special image. So I have two images basically. I have the one that just allows to run the resulting build by the build native image. And we will attach it, or the one that's usable for such configuration. Again, we have this tag. I built it from a Docker file. It contains GraalVM, or you can take a ready-made image by JetBrains. They have created specifically an image suitable to doing that. So we have port forwarding and other Docker parameters here. You have to specify that. And that's it. So it's 8083. Yes. And here we have a module specified. If the module is not specified, the sources won't be found. We're going to debug it. See, there's actually stuff. Oh no. So under the hood, this plugin starts GDB server in that container. So the container is started, the application is started, so it's mounted inside a volume provided with this container as this basement to run the application. The application was run and the GDB server has been started, and then the ID connected to the GDB server took some necessary information. So we now got the active debug session. So inside that session, we can go that just hit the breakpoint. I have a couple of breakpoints inside the controller in that Spring Boot application. And it's a native image. It's a native binary built in debug mode. We can add a build step right inside run in debug configuration to perform a maiden or Gradle build. And IntelliJ will add some debugging options automatically when it builds. So you don't have to change the POM file. You don't have to provide additional tricks to generate sources for debugging. It's all being done for you automatically. And it has some context. It's funny because in EAP, all that context worked, but surprisingly not all of it works now. But you see, owner ID here is an integer object, so we can see some internals of it, and we even can see a value. Unfortunately, in this version, we can't change it, at least on my machine, on Linux. I'm sure it will be fixed soon. So you see, we can debug it. And what's also interesting here, you see the stop thread, and we can even try to disassemble. So this part was brought from CLion. Like it's ID, but there are different IDs for different languages in case of IDEA, unlike Eclipse, where it's a single one. And we can look at registers and disassembly of the code and step in through assembly. Oh, it's kind of fun. But more complicated scenario is a touch. So we can manually, imagine we do it in Kubernetes. We manually build our application, some build host, deploy it somewhere, and it's built in debug mode. So it's our container started. That's a kind of production-like container, but we have added GDB there. It's not necessary. We can also provide an ephemeral container with GDB server. That's a good option. So we can log into that container Start the application manually. We do it manually. Again, we log into that container. We ask what are the processes, and we start the GDB server. So in this case, the PID of the Spring Clinic native image process is 59. So we just PID. We now have GDB server debugging our native image available in some remote container. We can port forward, access to that container, do all the security stuff. In the end, we get the port on our local host available for our ID. So that's the attached configuration. We say just go to localhost, and this port is forwarded to localhost. Again, use this module. We can provide symbol file just to let it not be downloaded from the remote host, from the target system. But in case we don't do it, it will be okay. And we just say, yeah, here's the sources. We can use additional source mappings because our local source structure can differ from what was used to build that native image. But that information available during the build has been written in the resulting image. And GDB server will tell us, hey, these are sources located in, I don't know, somewhere, sample, and we have them in a different folder. It may be a different user. We have to map them, so we can create mappings. So you see, the configuration is simpler, but basically it does the same. So we just go there, see debug. And the same thing happens. We connect to that remote container. We don't start it from the ID. We just connect to an existing. We don't read it. So it's I guess. And again, we hit that great point. Kind of easy, but sometimes it feels like. So the operating system support is fine. You can just use different operating systems for your host part, right? Just the target is obviously Linux container, but it will have a different architecture. Like on x86 machine, it will be an x86 container. On ARM, like Mac, it will be an ARM container. And there are multiple ways to go into that container for debugging. So different options are magically provided by the IDE. You can use one of images or build your own image. And this part will change from the next releases, but in current release, you can follow this. As I said, sometimes it's tricky. So yeah, call someone, call a friend if you have any troubles with it. And read more on Outlook. That's it.